So, as Claire mentioned, I'm Izzy, and I'm going to talk to you a bit about VSOCKs. So, this is a method which VM host and guest can use to communicate with each other without using a network. So, before we dive too much into this, I do have a few goals for this talk. So, the first is that you come out with an understanding of broadly what a VSOCK is, what they're used for, and a little bit on how you might use them practically in a project. Come out thinking VSOCKs are kind of cool and neat and underused, perhaps. And also, as Claire mentioned about the shilling Rust, maybe thinking Rust is good. So, what do I do? So I do triage incoming bug bounty reports for Microsoft. So it means I spend quite a lot of time looking at blue screens of death and then working out what actually caused that. So this requires me to set up a lot of Windows instances. And so once we've triaged the bug, we do some variant finding and we validate the fix once it's been written. I do some research as well. So I have this nice automation project, which I'll talk about in a couple of minutes. I shill Rust. And in case anyone wants to ask me questions about these, I don't have anything to do with Azure, Teams, anything web or online related. I don't know about bug bounty payouts. And I also don't write fixes. So the automation project that I just mentioned. So this, so because we are getting proof of concept code from researchers, we don't know if it's malicious or not, and we don't want environments to be corrupted by other proof of concepts. So we have to spin up a single-use network for a VM every time, and they ideally are not internet connected either. So to do this, I have this nice project which will set up a whole network. It has a little Linux router on it, and that uses Ansible. If anyone hasn't heard of that, it's mainly used for orchestrating like large networks more permanently, but we can use it here to do automated configuration of things like domain controllers, and it's really nice. So perhaps more helpfully, this slide has a nice diagram. So the main thing I want to focus on here is actually that SSH here is on the network. And this is actually a weakness because if it's on the network, other people on the same network as it can just SSH in if they can guess the password. And that's not ideal if it then has access to like a potential 0-day. So so in this initial instance, we do the setup and then we disconnect it from the internet. And then we run the proof of concept once we know the environment is configured correctly. Not quite ideal, but hopefully we can fix it. So to fix this, I discovered there's this thing called a VSOCK. And as I mentioned earlier, it does allow communication between a guest and host without a network. So it does this using the VM bus. And the way that the VM bus works is it presents a device to the virtual machine, and the virtual machine will then communicate with it with a protocol. So no network. Which is kind of neat. There are two main address families. There is AF Hyper-V and AF VSOCK. The main difference here is that one of them is more Windowsy and the other one is more Linuxy, but you can kind of cross-operate between them. I won't go too much into this specifically, though. And to be honest, you're probably already using them if you use VMs anywhere. This is how enhanced sessions work. And how all the guest integrations tend to work is they present devices which do each of these things over a VM bus. PowerShell Direct is another way of using this, which is just supported in PowerShell if you've installed Hyper-V. Sorry, I do use Hyper-V, so if you came here for Linux, sorry. And HVC, which I'll go into briefly as well. So that's Hyper-V Connect. That is talked about a little bit further on in this talk. First, I thought I'd talk a little bit about how the Kali tweaks works, which configures XRDP to use VSocket. Because this is probably what most people in the audience have used, right? So the first thing it does is it configures XRDP, so it installs it, it's not installed, and then it just changes the configuration to use VSocket. And then you run one PowerShell command to tell it to use a VSOCK instead of a HVSOCK in the host. And that's it. So what does that config change look like? Well, this is what it does. all it does is replace the port number with VSOCK : / and then that number again, which seems pretty simple. I won't show the PowerShell command that's used as well. You have to turn off the VM, run the command, and then restart it. Or if you think ahead, run it before you start the VM. So, can we do this for SSH? It turns out, yes we can. So, if anyone knows what the SSH config looks like, it looks exactly like this, except that we just add this VSOCK : ; and then if we restart the service, it will now listen on the VSOCK instead. We can test this by using HVC, as I mentioned it earlier. So, it comes with Hyper-V, and it's basically just a wrapper around SSH, SCP, serial, and a couple of other commands. And it's really nice. Not many people actually know it exists. It's super handy. And so I have a demonstration on the next slide. So here, all I've done is I've run HVC and then the normal SSH command. The only difference is that after the ampersat, where you normally specify the IP or the hostname, you specify the VM name instead. And then you SSH as normal. So I've got netstat here, and that shows SSH is just not listening on the network. But we've SSH'd in, which is kind of nice. So could we do this programmatically and in Rust? Well, it turns out HVC must be doing this, so we can. But AF Hyper-V isn't supported by any crates at the minute. VSOCK is supported by the Socket 2 crate, I believe, but not this one. So unfortunately, my rather messy code, which I opted not to include, is using some rather nasty raw syscalls from the Windows crate, some sad bindings to C, but importantly, it did in fact work. And so this gives us quite a few bonuses. I think that I get to talk about that slightly more later. But here's that nice diagram from earlier. So now we can just SSH via VSOCK. No network connection needed. We can do all our configuration with no network involved. This lets us have better control over the network. Over that Linux router without the network. And so what we've got is a few project wins. So it's more reliable, or some people would argue more predictable. We have no network attack surface anymore. We gain some potential new features. So in terms of more reliable, we get this cool new feature where when you connect the network adapter to the VM again, it sometimes might take a few seconds to get any network, which kind of annoying. It's acting as a router. I actually want the internet connection now. So we can reconnect it and then SSH in over the VSOCK before it's got an IP address and then run DH client. Magic! Instant connection. Maybe there shouldn't be that delay, but so nice. Just gonna drop back into this one. So the last attack surface, yeah, like I said, we now just have no network. We've got new features, so we can now copy files to VMs using PowerShell Direct. That is just a feature of PowerShell Direct. It's super nice. You can copy files, you can run arbitrary PowerShell, and it just works. And yeah, so I use this a lot for copying case files over, and yep. So, unfortunately, what I did want to add to this talk, but I didn't quite get time to, was I wanted to be like, yes, great, we now have support for AF Hyper-V in Socket 2, or similar, but haven't had time to quite publish it. So, I think this would be quite a simple change if anyone would like to take it on. Otherwise, I will eventually get around to it. So this Socket 2, it's quite an important crate for Rust because it's used in basically everything. And adding crate that support there would be pretty great. But also, no one really is aware of VSOCKs, I think, even though a lot of things use them quietly under the hood. And I think it'd be really cool if we started to see them more, because it's so nice to be able to gain reliability, usability, and more security. Just having this removed from the network entirely is magical. the other benefit that you get in terms of predictability is if, for example, your VM gets put on a different VLAN, which does happen, you now can't SSH in because it's just not there. So we are no longer reliant on the external network conditions at all, and it's just fabulous. And yeah, as I mentioned, to copy files directly to the guest and run PowerShell commands directly, and yeah, perfect. This is the bit where I wish that I had slightly more content, because I dramatically overestimated the runtime that I would have had. I'm very sorry. But I'm really hoping in this apparently rather brief talk that you've learned that VSOCKs are cool, and that we can actually gain usability and security. And also, yeah, they're just kind of neat. So, yeah, in lieu of more content, does anyone have any questions?
One of your main points was that reducing attack surface was achieved by removing the networking. Do you see a future as VSOCKs become more popular that they start to become attack surface of their own? I did a quick Google, and I got more hits for exfoliating socks than I did for exploiting VSOCks.
So the question was, do I foresee VSOCKs becoming an attack surface? So one of the things about VSOCKs is that to open them, you already need to have Hyper-V admin on the host. And so I think at this point you would have already compromised the VM. But I do wonder about whether it could be attackable going the other way, if a VSOCK already exists. And possibly, I think you'd be looking more for a problem with the protocol itself, though. So you'd be looking like for an issue in SSH, potentially, or the other carrier protocol, say IPv6.
SSH is a TCP encapsulated protocol. Does VSOCKs encapsulate the TCP in there, moving the IP there, or is it just something completely different?
The question was, is it encapsulated by TCP still? So effectively what I got, hopefully this answers the question. So effectively what I got from all my horrible raw syscalls was just a WinSock socket. And so I then just passed it to the SSH library that I was already using. So in exchange for an open socket via the network, I just passed it an open VSOCK socket. Does that answer the question? It was very seamless and magical when I could just go, here's a different number, use that.
A lot of your talk was using Hyper-V. Is it possible to do the same things with Linux?
So the question is it possible to do the same thing with Linux? I believe that it is, because you can have enhanced sessions on Linux, and Linux does have support for VSOCKs in the kernel code. Because guess what I ended up reading a bit of when I was writing this code. So I believe that it should be. It's just a slightly different address family on it. But because I was mainly focused on Windows, and Hyper-V didn't spend as much time on this. Anyone else? If anyone has any questions about bug bounty triage or anything, I can answer questions about this as well. Otherwise, it might be a rather early break. Michelle asks, has anyone asked about the ducks? What ducks, Michelle? Nope. It's a chicken back there, though. And we do have a QEMU. Yep, sorry this is underrun, but hope it was informative anyway.